Hi guys, this is Miss Lemons. This is the Combustion Lab demo. We're going to be using this hydrocarbon instead, and before we get started, I want to talk about the two different types of combustion that we know of. There is complete combustion, which consists of a hydrocarbon plus oxygen gas and gives us carbon dioxide and water vapor. Whereas incomplete combustion we start with, again, a hydrocarbon, oxygen gas, but this time we end with carbon monoxide, solid carbon, and still water. So take a look at the similarities that we have here. We start with a hydrocarbon, same. We also start with oxygen gas. These are exactly the same. And both of them end with water. The only differences between a complete and incomplete is that a complete combustion has carbon dioxide gas, whereas an incomplete combustion has carbon monoxide gas and solid carbon. So those are the two differences, or the differences between those two types. All right, so we're going to go ahead and assume that we're going to do the complete combustion of this hydrocarbon. So that means we will have oxygen gas yielding carbon dioxide gas plus water vapor, so steam. And we're going to balance this chemical equation. And just as a reminder, we always balance our metals first, our nonmetals second, followed by hydrogen, and then finally oxygen. We always leave oxygen for the last one. Now, I don't have any metals here, so I've already finished that. And the only nonmetal that isn't hydrogen or oxygen here is going to be carbon. I have 5 carbons in the reactants, 1 in the products, 12, 2, and 1, 2, 3 oxygens in the products. Okay. So I need to have 5 carbons in my products, so I'm going to remedy that by putting a 5 in front of carbon dioxide. And when I do that, I need to update my inventory. Now I have 5. Let's do that in a different color, actually. Great. But I also have to make sure that I update my inventory for oxygen. Now I have 5 times 2, 10 oxygen, but I also have this one here. So that's a total of 11 oxygen on the product side. I'm done balancing my carbons. Now I can balance my hydrogens. I have 12 in the reactants and only 2 in the products. So I'm going to remedy that by putting a 6 in front of my hydrogen. I'm going to update my inventory, which ends up giving me 12 hydrogen and 6 oxygen plus the 10 here, which gives us a total of 16 oxygen. Excellent. So we're done balancing hydrogen. Now we can finally balance oxygen. I have 16 in the products, and I need 16 in the reactants. So I'm going to put an 8 in front of this, so 8 times 2. That gives me 16 oxygen on both sides of the equation. Now our chemical equation is completely balanced. All right. So now that we've balanced our chemical equation, I'm going to build my reactants. Looking at the coefficients, I can tell that I only have 1 hydrocarbon, C5H12, and this is exactly what it looks like in 3D. It has 5 carbons, and it's got 12 hydrogens in it. Now, just for simplicity's sake, I've gone ahead and removed the bonds from it to create a flat version. I'll just place that right there. And then we have oxygen, which is a diatomic. It looks like this. It's got a double bond. It's bonded to itself. And we've got 8 of those puppies over here. So instead of making 8 of these, I've gone ahead and removed the bonds, and here are my 8 oxygens. So the rule here is that you can only use what you start with. You can only use the atoms that you start with to create all of these products, which seems a little bit crazy, right? So what this is showing ultimately is the law of conservation of mass. Let me show you why. We are starting with 5 carbons. We are also starting with 12 hydrogens and 16 oxygens. The law of conservation of mass tells us that mass cannot be created or destroyed. Which means that we should also end with the same numbers of each atom. So we should have 5, 12, and 16. Let's see if that happens. So I have to create 5 carbon dioxides and 6 waters based off of my balanced equation. I'm going to take 1 carbon and 2 oxygens for 1 carbon dioxide. There's 1. Okay, here's 2. All right, so there are my 5 carbon dioxides. And just so you guys know, this is what carbon dioxide actually looks like. It's got double bonds on either side. Great, we're done with carbon dioxide. I clearly cannot make any more carbon dioxide because I have no more carbon. I've used it all up. Now I can go ahead and make water. That's 2 hydrogens for every oxygen. So there's our first water. There's our second water. Oops. Oh no. All right, and I have 6 waters. As you can see, I didn't add anything to what I had on my reactants, and I was able to create 5 carbon dioxides and 6 waters. So if we count this up, we still have 5 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 oxygens, and we have 2, 4, 6, 8, 10, 12 hydrogens. So the law of conservation of matter is proved when we balance our chemical equation. And I want you to kind of think about this. What would happen if I changed this to a 7? That means we only had 7 oxygen molecules to work with. So an oxygen molecule is O2. So that means we would have to take away an oxygen molecule. And you could see here that what we've created essentially is a free carbon. So we haven't used it up. And we're missing an oxygen, okay? So it has to be balanced this way because it shows our law of conservation of mass. Now, if we were to do this as an incomplete, meaning we didn't have enough oxygen, we would end up with this free carbon, and these would form carbon monoxide instead. So now what I've just shown is an incomplete combustion. Clearly, we don't have the same that we started with at the beginning, okay? All right, so that is the gist of the combustion lab. You need to know that whatever atoms you start with have to be the atoms that you end with.